Hi everyone, my name is Pranav and welcome back to a new video. This time we're going to be taking a look at part 2 of the Python series. Today we're going to be discussing Booleans, conditionals, and loops. Without any further ado, let's get started. Here we are within our REPL.it code editor, which we used in the first part. Let's do a quick recap of what we covered yesterday. On the left hand side, we have our files panel as well as some other useful panels such as version control. We can actually add packages right over here and even use the debugger as well as edit some other settings. Here right in the middle is our actual main code file that we're going to actually edit our code in. We can run our code by clicking on the run button over here on the top, and it's going to run right here on the right hand side in the console. Now let's start with our first topic of the day, which is going to be booleans. If you remember from the first part, you can create a boolean just like any other type of variable. Let's say we want to check if, let's say we want to create a boolean variable to store if the bottle is full or not. Let us call this bottle, and we're going to say false for now. I'm going to just modify the variable name to make it bottle full, and let's say it is false for now. What we could do later on in our code through a variety of input and a bunch of other things is actually modify that later on to bottle full equals true. And we can actually use conditionals, which is the second topic we're going to be covering today, to check if the bottle is full and do something else if it is or if it isn't. But as for booleans, while this is one standard way of creating booleans, another is through the comparison operators part of booleans. What I mean is where you can compare two different elements, and that value right there can automatically be substituted for true or false. One example would be 1 is less than true, which is obviously true, right? And Python will actually automatically substitute this statement right here for the value of true. So instead of putting in true right here, we could actually just set bottle full to 1 is less than 2. There are a couple other examples we can use here, such as 4 is greater than 3, and say we wanted to use the lesser than or equals to comparison or the greater than or equal to comparison. Python has a way of doing that as well. We could do something like 6 is lesser than or equal to 6. And this is a special syntax we're going to be using within Python right here, where we're actually using the lesser than symbol, then the equal symbol together as a compound to basically denote lesser than or equal to. The same works for the greater than or equal to symbol as well. And last but not least, we also have the equals symbol. And what this is used for is for checking if something is equal to the other thing. For example, right here we're checking if 10 is equal to 10. But wait, you might be wondering why we don't just use the normal equal sign right here. Well, the reason is we're already using the equal sign for variables, and it means something other than equivalent. What it really means is assignment in the case of variables, but here we actually want to check if these two elements are equivalent together, not assigning them to each other. So these two symbols right here, just the equal sign and the double equal sign, mean different things. Aside from these, there's also one last one that I just missed, which would be the not equal to sign. But you rarely use this, as there's other ways to accomplish the same thing also. You could check right here, 1 is not equal to 2, as well as using other variables in the place of these for all of these examples as well. We can actually set our variables to any of these operations. Say 1 is not equal to 2. Right now that would equal true, but we can also make it 1 equals 2, which would equal false, or any of the other examples we used here with different values. But now, what is the actual purpose of using booleans? Well, they can be used within conditionals, which we started talking about in the start. The way we're actually going to be using conditionals is to check if something is true and perform something else if it is indeed true or if it isn't as well. For example, let us create a variable called raining and set it to false at the moment. This variable is just a placeholder, right? But we're going to be using it to check if the weather right now is precipitation or not. And now we're going to actually use a conditional to do something if it is raining and do something else if it is not. The way we're going to create this is first off by using the basic form of a conditional called the if statement. You can start one by typing out if, then the condition that you want to check, then a colon, then after that you can hit enter and type out a variety of statements that you want to perform if this statement or the condition is true or not. Let me just showcase this via an example. Right here I can check if raining equals true. This is the same syntax we use for all of those comparisons. But right now, if it is true, I want to print something, let's say. And like I said, this is the syntax that I just specified at the start. If, then condition, then colon, then an enter. And you can type out all of these statements that you want to use here by just having them indented. And this indent should be taken care of automatically. Let's say we want to print out take an umbrella in the case that it is raining. Now if I were to run this, we should actually get nothing because raining is false. If I change this to true, we would actually get take an umbrella. But what about the case that it is not raining? What if we want to do something in that case as well? That's where another type of conditional comes in, and this is known as the else statement. We can create one just by typing this, and this statement right here should not be indented, otherwise it'll become part of the if statements as well. Right here we're just typing out else, then a colon, and then after this you can type out all of these statements that you want to execute when raining does not equal true. Let's say we want to print out don't need to take an umbrella, and now if you were to click run, you would get take an umbrella here. But if I were to change it to false, it should actually test out this if case, and because it is not true, it's going to go to the else clause, and here it's actually going to print out this statement right here. Wow, it worked just as we expected. Now let's look at another example where we might need to use more cases than what's present right here. Right here, I'm actually going to create a variable called temperature and set it to 40, which is a placeholder at the moment. But I'm actually going to create a set of conditionals right now for different cases for the temperature. First off, let's start with a simple case. Say temperature is less than 10. In this case, what we're going to do is print it's cold. Then, what if, instead of checking if it's just greater than 10, what if we also wanted to check if it is greater than 80 as well? In that case, you could do another if statement as well right here. But what if instead of that, you want to connect it to this if statement right here and say, if temperature is less than 10, then do this, and else if it is something else, then do something else. That is a common statement that you're going to use within Python, and it's going to be called the elifs. The way we're going to be using this is by typing out elif just like the if and typing out a different condition from before. In this case, let's say temperature is greater than 80, and now let us print out it's hot. And if we had other such cases, we could actually continually create more elif statements such as this. But let's say we want to end it off right there. And now let's create one last clause right here for our else clause and say if it is not less than 10 or not greater than 80, it's automatically going to go to this else clause. And here we're just going to print it's normal because it's greater than 10 but less than 80. So that's pretty normal, I guess. Now if I run this, we're actually going to get it's normal. I'm going to quickly remove our other example from before so it's a bit more clean. Now if I were to change this temperature value to 8, we're going to get it's cold. And if I were to change it to something like 93, I would get it's hot. So in this example, our conditionals work just as expected. Next up, let's move on to loops. I'm going to quickly remove this code, and I'm just going to show you a quick way you can actually hide the code from the compiler. It's a shortcut right here, but I'm going to use command plus the / key to actually comment it out. And comments are a way in Python to basically type out text that you don't want to declare as code. The way you can do this is just by typing out hash, or if you want to comment out multiple lines at once, you can use the shortcut I just described earlier, which is going to be command plus the / key. I hope that helps you out. But it can also be used in a variety of scenarios, like right here. Let's say I'm going to say, let's create a loop. It can be really useful when you want to revisit your code later on or something like that. You can really use it right here to help you understand what you're doing within your code. Right now, let's actually create a loop. First off, what is the use case of loops? Well, let's say you want to just repeat something multiple times. That's the easiest use case of a loop, really. Like, let's say we have hello right here, and we want to print that statement out multiple times to the user. Right now, this might seem like a really useless scenario, but it can be used for a variety of things, like getting multiple things out of a list, or parsing through a list for each user ID and adding it to somewhere else, something like that. Right now, this is a simple example right here, but right now I just copied and pasted the print hello statement multiple times, and if I were to run, we get our expected result here. But this takes a lot more work, and let's say we have not just 10 items, but let's say we want to repeat something 100 times or more. It's going to be very strenuous to copy and paste each time. So instead of this, let's actually create a loop. The way we're going to create this loop is going to be using the for loop syntax. There's multiple types of loops, but the easiest one to understand would be the for loop. The way we're going to create this is by typing out for, just like we did with the if, elif, and else. The for is like a starting point, which lets Python know that we're actually creating a for loop. Then we're going to actually add in an I or any sort of variable right here, a variable name. Then we're going to type out in. Then right here, you're actually going to need to add in some sort of list or array. But in this case, when you just want to repeat through something, like you don't actually want to iterate through a loop, or in the case that you don't want to actually iterate through a list and instead just want to repeat something, you can instead use another function called range. This function will let us actually return a list of numbers 1 through something or 0 through something. You can pick the range of numbers that you want to go through, but we can actually iterate through those numbers to help us achieve the result of repeating something some amount of times. Let me show a quick example right here. This would be a very simple syntax for a loop. What is actually happening is our I variable right here, and this variable name can be anything, by the way, but our variable I right here is actually going to be iterated, and it's going to change value each time our loop runs to go through every number within this range list. And so that means that our loop is actually going to run that many times, whatever is within our range function right there. And each time it runs, it's going to do whatever is within these colon right here, whatever is after the colon right here. And it's going to print out hello in this case. But as for our range function, we can simply declare a range by typing out a starting index and an end index. But wait, there's something of note right here. In Python, the range function works unsimilarly to real math, where the end index is actually not included. So if you actually want to do 1 through 10, you're going to have to change the end index to 11, because what actually happens, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it stops right before the 11th. Instead, if we change this end index to 10, it's going to stop at 9, which is not the expected result. Let's actually remove this code below right now and run our code now, and we get the expected result in a much easier way. But here's the thing, like I said earlier, this variable I right here is actually changing each time our loop runs to go through every number 1 through 10 in our thinking way. 1 through 10 in our numbers right here, right, in our range. So the way we can actually use that variable would be to just print out I maybe, so I can showcase this. But if I were to run right now, we would actually get all of the numbers 1 through 10 in a much more convenient manner. You could also do this for any number of digits as you would want. Say you want all the numbers 1 through 100, that is possible as well. So I think that's a brief introduction on for loops. We're going to explore them more in depth in the next part, which is going to be releasing very soon. But let's quickly look at another type of loop as well, which is going to be called the while loop. I'm going to quickly comment out this code real quick. And as for our while loop, the way it works is basically by, let me just write out a quick example. So here would be the English or pseudocode way of writing out a while loop. While condition, it's going to perform something repeatedly while that condition is true. For example, we could check if 0 or let's say 1 equals 1, which is obviously going to be true, and print out hello each time. Now this is actually a very bad example of what to do in code, but let me just show an example. Right here, hello has actually been repeated infinitely, and as you can see on the side right here, I'm actually scrolling through the list and it's actually continuing infinitely on. So this is really bad. But what we actually need to do is modify our code here so our condition at some point becomes false. Otherwise our loop is just going to continue on forever. The way we can do this, it would be through a simple example. Let me try replicating what we had right here and trying to get all of the numbers 1 through 10. Let me create a quick variable called I, just as we did before with the for loop. And here, instead of checking if I is instead of checking if 1 is equal to 1, I'm going to check if I is less than 11. Right now, if I were to run, I would actually get the same result because I is still not changing. But within my while loop, what if I instead set I to be 1 times greater, like incrementing I by 1 each time our loop runs. So instead, what if I actually increment I by 1 each time by adding this simple operation right here, which we've discussed in the first part, where I'm actually modifying the property of I, the value of I, to be I plus 1. So each time it's actually going to increment by 1. Now if I were to run, what's going to happen is it's going to print hello 10 times. Because each time I is going to increment, and at some point I is going to reach 11. And at that point our while loop is going to not work anymore. Alright, we're back. Looks like there was a brief disruption around my screen for some reason. But right here, back to the example, we're just checking while I is less than 11, we're going to print out hello and increment I by 1 each time. So it eventually stops because the condition will no longer be true when I hits 11. To showcase this, I'm going to run again. And now we just get hello 5, 10 times right there, just as expected. And to actually get the same result as what we did in the for loop, I'm going to print out I, and we're actually going to get the same result, 1 through 10. Just as expected. So in this way, the while loop and for loop can actually be used for similar things at times, but they can also be used for very different scenarios if you want them to be. This was a brief introduction of them, but I hope you enjoyed this class. This is the actual end of the second part, and the third part will be releasing very soon, so stick out for that. Thank you for watching. I hope you can subscribe down below to my channel to get lots more cool coding videos such as this. You can also hit the like button so more people can get this video recommended and more people can watch it. Also, make sure to hit that bell icon next to the subscribe button to receive notifications whenever I upload a new video. Thanks for watching and cheers.